All right, topic 1 of our factoring unit introduces us to factoring in general and just kind of explains what it is. But the main focus is going to be on factoring out the greatest common factor, which is something that you learned about way back in the day. If I give you 24 and I give you 16, I want to find their greatest common factor. Well, first of all, what's a factor, right? A factor is one of the pieces that makes up a multiplication problem. It's the original piece, right? So for 24, I could start listing their factors by writing out what times what gives me 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's really all I got. Those are all the factors of 24, okay, because those two things together multiply give us 24. 16, I can do the same thing. 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, which is really itself, so I don't need to write it twice, but you get the point. So if I wanted the greatest common factor, I want to start looking at my bigger numbers, right? So 24, well, no, that's not in both of them. 16, no. 12, no. 8, I see over there on the 16, and I see here. That would be the greatest factor that I have between the two, okay? Quick little review right there of just greatest common factor. We're going to extend this to polynomials, obviously, because we are in algebra, and it'll make more sense here in just a second. So what I want to start with is just a multiplication problem. So if I gave you this little distribution problem, we would distribute 3a to both of these pieces, right? So 3a times 2, 6a, 3a times 5a, 15a squared, right? Okay, well, what if I decided that I wanted to cover up, let's keep a little heart. What if I wanted to cover up the original problem, and I said, hey, what was the original problem? And I wanted you to start with using that 6a plus 15a squared, okay? That right there is factoring, okay? So if we were to write a quick definition of factoring, I would just say finding the original factors, probably should write smaller than I am, original factors of a product. And again, a product is the answer to a multiplication problem, okay? So let's just kind of talk about that problem up there, 6a plus 15a squared. If I wanted to undo that and rewrite it as a multiplication problem, something times something, remember that that's what it looks like, right? I want to look at and see, well, what was maybe distributed into both of them? Well, they both have an a, right? I can see that there's an a here, and this one has an a squared. So I bet an a was multiplied in. Now let's think about it. Was an a squared multiplied in? Well, no, because this one doesn't have an a squared. So just one a is really all that was multiplied in. Okay, I look at 6 and 15. I think, okay, what could have been multiplied to both of those? Because I know something was multiplied to both. The only thing that they both have in common would be a 3, right? Well, again, okay, 3 times what would give me 6? Well, it had to be a 2, okay? Over here with the 15, 3 times what would give me 15? Well, 5, right? But again, I had a squared, so I need another a there. And you'll see that that was our original problem. 3a times 2 plus 5a. That really is factoring. We just did factoring the greatest common factor, okay? We're about to do a whole bunch of examples. I'm not going to work them all out on this video because I want to try to keep this video less than like 7 minutes. That's my goal every time. But I will work a few, and then I'll pause the video. You can pause it as well and work some out, and then I'll replay it with all my answers shown, and you can check yourself. So let's keep on going. Okay, so again, here's just some practice problems. Number 1, 8ax minus 56a. Again, I'm trying to turn this into a problem where it looks like multiplication, it looks like distribution, right? So I look at the greatest common factor that each one has. Well, let's start with just the numbers, 8 and 56. The greatest common factor between those two is 8. 8 is divisible into both of those terms, right? Now I go to my variables. Well, they both have an a. Only one of them has an x. So that means an x was not distributed into that. Otherwise, the 56 would have an x on it, right? So 8 and a is the greatest common factor of that binomial. So then I'm going to open up my parentheses, and I think, okay, 8a times what would give me 8ax? Well, x, right? Minus 8a times what would give me 56a? Well, 7. There's your answer. Moving on. Number 2, same thing, okay? I'm going to start with my numbers, 6 and 42. What is the greatest common factor of 6 and 42? Well, 6. Okay, that can go into both of them. Then I look at my variables, x squared and x squared. Well, since they both have an x squared, I can actually take out the x squared. Okay, I'm taking out x squared from both of them, which again kind of even looks like the opposite of distribution, right? Now y, only one of them has a y, so I can't take a y out of both, so it's not going to be one of the greatest common factors here. So I draw my parentheses and see what would be left over. Well, I've taken out the 6 and I've taken out the x squared. All that would be left is the y, okay? Plus, I took out the x squared already, but I still have 42. I'm taking 6 out of the 42. Now remember, distribution, when you're distributing, is multiplication, right? So what I'm doing right now is kind of like division. So I want to think about 42 divided by 6 would be 7. Okay? Number 3, 14 and 18. Well, think about my factors of 14. 1 and 14, 2 and 7. That's it. So really the only thing I just listed out that 18 has in common is a 2. Okay, then I look at my variables. I've got xz, xz squared. Well, they both have an x. They both have one z, z to the 1, but I can't do z squared because 14 doesn't have a z squared. So I can take out the greatest exponent possible, which in this case is just a 1. Open up my parentheses, so I've got 7 minus, 9z. Let me make that for you. 9z. Okay. All right. I'm going to pause, work out the bottom 3. Y'all try to work them out as well, and then let's compare. Okay. I just realized that my video is already at 6 minutes and 40 seconds, so there's no way this is going to be 7 minutes, but hey, it's the first video. I feel like it can be a little longer. So there's my 3 answers for 4, 5, and 6. Kind of glance through those, make sure you did okay. The one that you probably got tripped up on is number 5, and you'll see there that I have a weird answer. My answer there is prime. Okay, if we think about what prime and composite mean, a prime number is one that only has factors of 1 in itself, right? Well, if I look back at all these problems I was just working through, this is a multiplication problem, okay? Just like I can rewrite 24 as 6 times 4, I can rewrite 8ax minus 56a as that right there, okay? So all of these problems I'm really breaking down into something times something, something times something, something times something, something times something, right? Well, this problem, number 5, I can't break it down into anything. There is no greatest common factor that all 3 terms have in common, right? Yes, these both have an x, but 7 doesn't. Yes, this one has a y, this one has a y, but 5x doesn't. So there was nothing I could take out, meaning I can't write it as something times something. Just like 6, no, not 6, sorry guys, it's a little early in the morning. Just like, try again, just like 5, is what I meant to say, cannot be written as anything besides 1 times 5. I can't write this thing as anything but 1 times that. So that makes it a prime polynomial, just like this is a prime number, okay? So sometimes you get those, not very often, so please do not write prime on every single problem that looks hard. But that is a prime question because there is no greatest common factor, okay? Alrighty. So again, this is just more practice. I'm going to do one more with you verbally, and then again, we'll pause it, and we'll go back through and chat, okay? So I'm going to do number 7 with you. I'm looking through these 3 terms this time and seeing that all 3 have to have the same greatest common factor. So I've got 8, 4, and 12. That means 4 is my greatest common factor there as far as the numbers are concerned. My x's, I've got x to the 4th, x to the 3rd, x squared. Well, the biggest x I can take out would be x squared, okay? Then I've got my y's, y to the 3rd, y to the 3rd, y to the 3rd. Obviously, I can take out a y to the 3rd. So let me open up my parentheses. From that first term here, if I divide out the 4, I've got 2. If I divide out the x squared, I've got x squared left over. Y cubed is taken out already, so that's not there. Okay, my second term, plus, I took out 4 already, so the 4 is not there. Took out x squared from x cubed, so it's just x. And I took out y cubed already, so it's literally just an x. Last term, plus, taking out the 4 from 12 gives us 3. I took out an x squared, and I took out a y cubed, so that's literally all that's left. Okay, so again, try to pause it, work through these remainder 4 problems. Remember, the greatest common factor has to come out of every single piece. Even if there was 12 terms in a polynomial, you would have to have the greatest common factor of all 12. So I'm going to pause it now, work through the rest, and y'all do the same. Alrighty, so here's my 4 answers. Again, you'll note number 8 was prime. There was no greatest common factor between the 2. Once you saw that the variables were different, we had r, s, d here, and then we had wn, there was no variable you could take out. So you were really just dealing with 9 and 56, okay? One thing I'd like to point out is number 11 was kind of funky. On number 11, when you factor out the greatest common factor, which would be 3a squared b cubed c, you're left with 5 minus 7 in parentheses. Well, if we PEMDAS that, what is 5 minus 7? Well, it's 2. Well, what is 2 times 3a squared b cubed c? It's 6a squared b cubed c. Now, we could actually get that before we even started this problem, just by recognizing that these two things were actually like terms. Okay, we could have just subtracted just from the beginning, because they have the exact same variables with the exact same exponents. You'll notice no other problem has been like that, because they all have different sets of variables and exponents, meaning we can't actually combine them, whether through subtraction or addition. But number 11 was actually just kind of a random problem we threw in there just to see what you thought. And if you factored it, you would get this. But if you notice it was like terms, you would get this thing down here. Okay? All right. Yeah, I was totally crazy. This is not going to be less than 7 minutes. All right. There's a few word problems that I wanted to just kind of expose you to. Don't stress over these whatsoever. This is not the end of the world if you don't understand, but I do want to show you. Write an expression in factored form for the area of each shaded region. Factored form means you've written it as a multiplication problem, something times something, okay? Now, we're going to have to do a lot of math before we ever get to that point, so you may actually be writing it in a different way at the beginning, but you'll eventually get to that factored form. So let's first just recognize what our side links are. This little rectangle is x by y, okay? So we're going to do the big area minus the small area. I can already tell you the small area is just xy, right? Because it's length times width, x times y. But now the big area is going to be this times this, right? Well, I know that this border everywhere is 3. So from here to here is 3. And from here to here is 3. Well, I know that this distance in the middle here is the same as this y up here. So my side length will be y plus 6, because I've got 3's added on each end. Same vertically, right? I know that this from here to here is 3. This from here to here is 3. And this middle section, looking here, is x. So x plus 6. So I'm going to go ahead and down here out to the side, go ahead and just work out what is my area. So I'm going to multiply x times y, so I get xy, x times 6, so I get 6x, 6 times y, and 6 times 6. Okay, now I actually can't combine anything there because I don't have anything that's a like term. So I need to have that first. Can't see my own board. xy plus 6x plus 6y plus 36. Ooh, minus xy, right? Because that was the small area. Well, when I go to actually subtract this, I see that really xy minus xy, those just cancel, and I'm left with 6x plus 6y plus 36. Now you'd think that's your final answer, but I go back up to my instructions and they want it in factored form. So they want my answer to actually look like a multiplication problem. So what is the greatest common factor of these three pieces? Well, 6. I'm left with x plus y plus 6. That is my true final answer because it's actually written in factored form. Okay? You might have to watch that a couple times to follow all that, but the important part is going from here to here. Alrighty, this one very similar, big area minus a small area. So I've got a square here. If I know every radius is r, then I've got 4 radiuses as my length. Same with across, radius, 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 4 radiuses. So my big area is 4r times 4r, which is 16r squared, okay? Then I want to subtract the small area. Well, that would be the 4 circles combined. So one circle I know can be found by doing pi r squared. So I've got pi, my radius is r, so it's literally just pi r squared. But I have 4 of them, right? So if I multiply this by 4, I just have 4 pi r squared. So I move that down here. Well, these are actually like terms because they both have a radius squared on them. Pi, remember, is not a variable. However, we don't want to actually have to use pi and multiply it out and get a weird decimal. So we're just going to take this thing right here, and let's just factor that, right? Putting it in factored form means writing it as a multiplication problem. Well, what is the thing that they have in common? Well, they both have in common an r squared, an r squared. They both have in common 4, right? They don't both have a pi, so I'm going to leave that in there. So I've got 4 here minus pi. that would be my answer. Again, not the end of the world if you don't understand this. It's not going to be on your little quiz or anything, but just want you to see some examples. All right, last two problems. So let's just keep this video under 20 minutes, yeah? Number 13, the area of a rug which is shaped like a rectangle. I always draw a rectangle. The area is 4x squared plus 4x squared feet. Factor this to find the dimensions. So this is different. For the past 6 months, I have been having you draw the dimensions of the rectangle and find the area. But for once, this time I'm giving you the area and wanting you to go backwards. Well, we know that this is a worksheet about factoring, right? It says factor. So ignore the fact that it's a rectangle. Let's just factor this. I can take out 4x, and I'm left with x plus 1. Ooh, tricky. We haven't talked about that yet. If you take out a 4x from a 4x, you're dividing. 4x divided by 4x would be 1, right? You also have to think about it in terms of distribution. 4x times what would give you 4x? Well, you have to have a 1 there, right? Okay, side note. So we have now found the two pieces that multiply together, right? Well, they said to find the dimensions. Well, they're basically saying if you had that area of 4x squared plus 4x, how did you get it? Well, we multiplied length times width. That means one of these is the length and one of them is the width. So maybe x plus 1 goes here and 4x goes there. And those would be your two dimensions. Okay? All right, last one. If xy equals 7 and x minus y equals 5, then x squared y minus xy squared equals what? This is kind of one of those problems where you look at it and you're like, what the heck is happening, right? You just kind of have to start thinking through your little algebra brain and think about what skills do I know? What things do I know how to do in algebra that I can just apply to this problem? And one of the skills you're now learning is factoring. So I'm going to take this piece right here, and we're going to factor out the greatest common factor, which I see would be x and y. I can't square anything because they don't both have an x squared and they don't both have a y squared. Open up my parentheses, and I've got x minus y. Okay? I factored it, but now let's look and see what they told us originally. They said, hey, xy is 7. So they're saying this thing is really just 7. And they're saying x minus y is 5. Okay, so this thing is really just 5. Well, I know that this is being multiplied. Well, what's 7 times 5? There's your answer. Okay? Alrighty, so your next steps would be to continue on in your folders. Next, you should find some independent practice where you're just going to work through this and check yourself with an answer key as you work along. You're going to submit it back to me. That's how you're allowed to move on to the next step. And then you'll take a quiz, which you have to make at least an 80 before you move on to the next folder. So if you have any questions or you feel like you need more practice or you need more explanation, please make sure you come and talk to me. If you're totally understanding and you're getting it and you're ready to move on, then just work your way through the folders. It should be pretty self-explanatory as far as what your next steps are and what you can do next. So hopefully you are a pro at factoring out the greatest common factor.